All right, so this is my third attempt at this thing. Hopefully there's audio. We'll see. Let's see, where am I at here? This is the wrong thing. Okay. Okay. So I guess let's take it from the top. Let me get rid of this problem. We'll come back to that in a moment. And let's bring in the first one. So it's the 22nd. Okay. All right. So here's the first problem. It says determine whether the ordered triple given is the solution to the system of equations. So we have a system of equations here, and then we also have this ordered triple. And the ordered triple is this number right here. So an ordered triple is a point in 3D space, or I should say gives the coordinates, describes a point in 3D space. You're used to seeing ordered pairs. So 1 and 2. Okay, so this is 2 dimensions, so it only has 2 coordinates. And how do those work? The pair means there's 2. The order means it goes X and then Y, the alphabetical order. But in 3-dimensional space, a point has 3 coordinates, X, Y, and Z. So when we started learning about systems of equations in algebra, we knew that the intersection of 2 lines was a system, the intersection of 2 lines was a point. And that's expressed by an ordered pair. But in 3-dimensional space, the intersection of 3 lines is also a point. It's just expressed with 3 coordinates. So that's what we need to check and see if this is a solution. So we can actually do this in the same way that we do it for 2-dimensional space. You just have to recall what the definition of a solution is. A solution is a value that when substituted into an equation makes the equation true. So we just substitute. We see if this makes each equation true. So let's put these values, and let's remember that this is an X, this is a Y, and this is a Z. So we're going to plug those into each equation that we're given. So let's start with the first one. 6x minus y plus 3z should equal 6. Let's see if this works out. 6 times 6 is 36. Negative 6 is positive 6. And 3 times negative 2 is negative 6. So we would like for this to be all equal to 6, but we know that 6 minus 6 is 0. It gets 36 equals 6, which is absurd. So this is not a solution. Ordered triple is not a solution. That's our answer there. Okay, so easy peasy. Let's go ahead and move to the next one. That's the one we just done. Let's try this one. Okay, so here we need to solve the system. And so this tells us that there's the option to have no solution and infinitely many solutions. So let's write this thing down in the coefficient matrix. So we're going to go 3. So we're going to go 3, 1, 5, and 3. So this is everything to the right of the equals. So we'll just put a little thing there. Then we've got 8, negative 3, 3, 1, negative 6, negative 2, negative 10. So with this, once you get this matrix, you can use Gaussian reduction, right? Just doing your row operations. But something that I'm always looking for is I'm trying to see if one row is a multiple of another row. Okay, and what I notice is that negative 2 times row 1 is equal to row 3. Okay, all except for these last things on the right-hand side of the equation. So what I'm going to do is I'm just going to do a row operation. I'm going to do -2 times row 1 plus row 3, and I'm going to store that into row 3. And let's see what happens from there. So the first 2 rows don't change. We're only changing row 3. So I'll copy the first 2 rows down. We get 3, 1, 5, 3, 8, -3, 3, and -1. Then we've got negatives. Oh, actually, this is the row we're changing. So I want to try something real quick. Let me see. I think these rows are all empty. Let me just leave them. I want to add a thing to this, and then I'm going to paint this entire deal, and then I'm going to try and erase a section of this. So where are we? This one I'm going to go. Okay, so here is our matrix. Now, our row operation, the thing that we're doing is we are doing -2 we're doing -2 times this row, and we're doing 1 times this row. We're just going to add those together. So actually go this, so we don't even need to see that. Here we are. Okay, so we're going to do the same thing to each row, and I wonder if I can just come from to yeah. Well, it's not going to come that long. Okay. So what we're doing is we're trying to do 2 times row 1, -2 times row 1 plus row 3. So that's all going to go into. So -2 times 3 is oh, actually, we just want 2 times row 1. So 2 times row 1 is 6, plus -6 is 0. So what you get is you get a 0 right here. 2 times 1 is 2, plus -2 is 0. 2 times 5 is 10, plus -10 is 0. 2 times 3 is 6, plus 8 is 14. So when you get something like this on the last row, you actually have an inconsistent system. 0x plus 0y plus 0z equals 14. That's what that says. But, you know, this is all 0, which is equal to 14. But this is absurd. This can't happen. So you know that this doesn't work out. This is not consistent. And when you get something like that, that means there are no solutions. No solution. The other thing that you could get, which isn't the case here, is if you had all zeros. If you have all zeros, that means there are infinitely many solutions. But that's not the case that we had. Okay, let me go back and just make sure the stream is still working. We have 2 concurrent viewers. Hey viewers, thanks for viewing. Say something in the chat, like the video and all that. Let me know how I'm doing. All right, so just kind of repeating some problems that we did on the last stream. Let's see, so picture. So we did not that one, did that one, did that one. Okay, so this is the next one we're on. I think we are. All right, this is our next one. So what we need to do is we need to make a system of equations out of this problem. We know that we need to do this because that's the material that we're working on in this class right now. But let's just read it and see if we can get the same intuition. So it says a stadium has 51,200 seats. Seats sell for $30 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the sum of the number of seats in section B and C. For each sold out event, the stadium takes in $1,217,500. How many seats does each section hold? Okay, so I can see that there are 3 equations here. And this takes some practice. Like, you're not going to be really good at this every time, but the first thing you want to do is identify what the unknowns are. Okay, and actually in this case, that's what it's asking us. Let's see. Sorry, I'm just adding back this image. Okay, and there we go. Okay, so let's see if we can write up some equations. The first thing is that my unknowns are how many seats are in each section. Okay, so I'm gonna just declare those. A is number of seats in section A. Okay, and we can say this for all of the rest of them, but you know, it's like, it's pretty clear that's what we're doing. So number of seats in section C. Okay, these are our variables, and we need to keep that in mind. That's really important for us. So let's try and figure out one thing. What is the total of the seats? Okay, so the stadium has 51,200 seats, and if there are only 3 sections, they have to come from those sections. So we're going to assume that A plus B plus C is the total number of seats. I think that's a pretty safe assumption. The next sentence gives us another equation. It says, well, in part, so we need to take it from 2 pieces. We're going to take it from here and from here. Those 2 spots are going to give us everything that we need. So if we sell seats in section A for $30, so $30 times the number of seats in section A, plus $20 times the number of seats in section B, plus $15 times the number of seats in section C. This should be equal to the total amount of money you would get from a sold out arena. This is 1,217,500. So 1,217,500. The last thing, I'm going to write this sentence to the side. This one is here. Okay, so this sentence reads, the number of seats in section A is equal to the sum of the number of seats in section B and C. So A is equal to the sum of B and C. Okay, that's what this sentence says. But that's not in standard form where like the variables are all on the left and the constants are on the right like the other equations are. So I want to just subtract B and C from both sides and get that into standard form. Okay, so this is the equation that I'm going to use. A minus B minus C equals 0. And now you can see I actually have a matrix. This is what I'm looking for. I'm going to strip away all of these variables. They're not super useful to me, and I want the coefficient matrix so that it's a little easier to work with. So it's 1A, 1B, 1C, and 51,200. And we'll just put this for, make like an augmented matrix here. Then we have 30A, 20B, and 15C. And this is 1,217,500. If I were doing this, I probably would have not written out these full values. Then we've got 1A, negative 1B, and negative 1C, and then 0. Okay, so here's our matrix. So you can always just use Gauss-Jordan reduction. And I think actually that's probably a good idea to do. So this point here, this is our pivot here. So we want to just go ahead and eliminate everything below that, okay, with row operations. So my first row operation, I'm going to do negative row 1. Actually, let's do row 1 minus row 3, and I'm going to store that into row 3. So we're going to keep row 1 the same. And we're going to keep row 2 the same. Those aren't being edited in this operation. And I think it's, you know, as you get better and better at this, you might kind of do 2 row operations in one step, but I don't recommend that until you feel really comfortable. So row 1 minus row 3 is going to give us 0. 1 minus negative 1 is 2. 1 minus negative 1 is 2. 51,200 minus 0 is 51,200. So this is our next matrix. And then let's eliminate that 30. So, sorry, hopefully this didn't go crazy. I just kind of kicked it. Let me check and make sure everything's still going. Boom, 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 boom. Okay, it looks fine. Y'all let me know if we get disconnected. All right, so I'm going to do 30 times row 1 minus row 2, and we'll store that into row 2. That's going to be our new row 2. Take that up here. Okay, so row 1 doesn't change, so let's just copy that. 1, 1, 1, 51,200. Then here comes, actually, let me do row 3. So we've got 0, 2, 2, 1,200. And then row 3. So 30 times 1 minus 30 is 0. 30 times 1 is 30. Minus 20 is 10. 30 times 1 minus 15 is 15. And then this is an unknowable number. So 30 times 51,200 minus 121700 is 318500. Okay. So now our new pivot point is going to be this guy, and we want to eliminate this way. I'm going to just divide row 2 by 20 on both sides. Or actually, no, let's not even do that. Let's leave it just the way it is. Okay, here's my operation. We're going to say row 2 minus 10 times row 3. It's going to go into row 3. Okay, so row 2 is 20. 10 times row 3 is 20. So 20 minus 20 is 0. So let's just copy everything down. And we're not changing row 2. Okay, so 20 minus 20 is 0. And 15 minus 20 is negative 5. And then 318,500, 318,500 is 10 times 510 gives us negative 19. Okay, and so on this one, you can divide the bottom row by negative 5. Get so dividing both sides by negative 5, you'll get 1 and then 387. 0. And then this should be enough to back solve. So I'm going to make some space here. And one of the other, I attempted this video. Actually, I'm going to leave this one up a little bit before, and I did it a different way, which I prefer, but this way. Okay, so we know that z equals 38700, which means from the second row of my matrix, I can say 20y plus 15z, so I'm going to substitute z, equals 318,500. Okay, and then I can just solve this. I'm going to subtract this over and divide by 20. So 318,500 minus 15 times 38700. Oh, that's a negative number. That doesn't feel right. 15. So I made a mistake somewhere. Okay, I'm just going to do this the easy way. So we're going to do row 1 plus row 3. This is going to go into row 3. You can see because this plus this is just 2a, but this plus this is 0. This plus this is 0. So this is going to actually just immediately be a. So row 3 becomes 2a equals 51200. So 51200 plus 0 is 51200. And then this plus this is just 2a. Then I can divide both sides by 2 and get 25600. So we know a, 25600. Once we know a, we can substitute that into our equations. So substituting that into the first equation, I get 25600 plus b plus c equals 51200. and I can subtract 25,600 from both sides. And this becomes b plus c equals 51200. Now, I can do the same thing in the third equation. So let's go ahead and do that. So we've got, so this is from equation 2. Now, oh no, I'm sorry, that was from equation 1. From equation 2, I'm going to substitute in the a that we found. So we'll get 30 times 25600 plus 20b plus 15c equals 1,217,500. Okay, so multiplying this together and then subtracting it from both sides, we get 20b plus 15c equals 217,500. 30 times 25600. Okay. So now we have two equations and two unknowns. I can just take these two equations and make them into a new matrix. That's this one and this one. So we're going to have b plus, actually I'll just leave it there, and then we'll do 20b plus 15c equals 449,500. And we can kind of eliminate this in the same way. I'll do negative 15 times the first row and add it to the second. So negative 15 times b is negative 15b, plus 20 is 5b. Then negative 15 times c plus 15c is 0. Negative 15 times 51200 plus 449,500. What is going on? Oh. No? Oh, I see what I've done. So when I did this right here, I didn't actually do it. So canceling from that both sides gave me c equals 25600. Okay. And then bringing the other one over is 20b plus 15c equals 449,500. So same row up. We're going to do negative 15 times this one, add the rows together. We get 5b, negative 15c plus 15c is 0. And then this is okay, doing it live. So this becomes that, and then we just divide by 5 on both sides. And what do we get? 13. Yeah. And so now we know B and C. Or I'm sorry, A and B. So to figure out C, you can just use this equation. So A minus B minus C equals 0. Which came from A equals B plus C. Right, so we just added B and C to both sides. And so we know that from this, C equals A minus B. I just subtracted B from both sides. So that means C equals 25600, substituting those values we already found, minus 13100. Okay, that was a mess. What does this become? This is 12,500. And what I would do is go back and actually check this in these equations that we started off with. Okay. So go back and check this and make sure it makes sense. So the total number of seats is 51,200. If you add those three numbers together, you'll get that. And then if you substitute into there, you'll get that. And this obviously works because it's the same information as this equation. That's where we got it from. So that went really poorly, but there you go. That's the answers. Let's see. I have no idea what's next. So downloads. Then we get this one. Okay, so here's another. I'm just going to keep kind of moving along on this. Okay, so at a family reunion, there were only blood relatives consisting of children, parents, and grandparents in attendance. There were 200 people total. There were twice as many parents as grandparents and 20 more children than parents. Okay. How many children, parents, and grandparents were in attendance? Ooh, this is interesting. So the issue is that you could be both a grandparent and well, obviously if you're a grandparent, then you have to be a parent. And if you're a parent, you can still be a child. So I wonder if they allow for double counting. Okay. So everyone is related. 200 people in total. So my thought is that if you did children plus parents plus grandparents, it should be equal to the total number of people. But I think if some can be double counted, then that wouldn't work out. So maybe this is just a bad problem. But let's see. So there are twice as many parents as grandparents. So if you did 2 times parents, this should be equal to the grandparents. And then 20 more children than parents. So if you did children should be equal to parents plus 20. So this should give us enough. And this one you can put this into a matrix. Like if we solve for all of our variables on one side, we can make a matrix and try to do an elimination or something like that. But we might be able to get this by just by substitution. The first thing I see is we could substitute this in for C here, and then we could substitute this in for G here, and we'll actually get everything in terms of 1. So if C is equal to P plus 20, then I'm gonna work from the first equation. So here's equation 1. I'm essentially working from this. So C is P plus 20. So that came from here. P, I'll just leave alone. We're gonna get everything in terms of P. And then G is actually 2P. So this whole thing is equal to 200. So let's combine like terms. We've got P plus 2P, so that's 4P, plus 20 equals 200. And we can solve this. This is just one unknown. So I'll subtract 20 from both sides. And then divide by 4. So this is going to be what? This is going to be 45. And 60 plus 20. Yeah. Okay, so P is 45. So I have reservations with this because, you know, if these people are all blood relatives, then some people could be parents and grandparents, and parents and children, or, you know, something like that. So I don't know if this will work out, but let's see. So then once we know what P is, we should be able to go back to this original set of equations. Like let's take equation 3, for example. And we can plug in 45. So children is equal to parents, which is 45 plus 20. And so that means children is equal to 65. And then there's a lot of grandparents. Also, we can, from equation 2, we should be able to get grandparents. So 2p is 90. And this looks like it doesn't work out. This doesn't work out. Actually, no, it does. It does work out. 65, so this one is the check here. So 65 plus 45 plus 90 is actually equal to 200. So everything worked out. I think that this is a bad problem. Just because, you know, you can get a situation where, like, let's say, you know, Tina has 2 children, and Susie and Paul. And then Paul has a child, and Susie has 3 children, right? So these people are parents, but they're also children. So I don't know. I think that's a little bit silly. So you get some overlaps between parents, grandparents, and children, right? You can be all of these things at once, actually. Here, super lucky. Okay. That. All right. So that's the last one there. Let's try. And here comes one. There's like a second email, so I'm probably not going to make it through all of these right now. I wasted a bunch of time just like doing this without audio, so I have to delete it and re-upload. Okay, so Lana offered to buy groceries for her roommates Pam and Cheryl. Total bill was $89. She forgot to save the individual receipts, but remember that Pam's groceries were 5 cents cheaper than half of her groceries. Okay. And that Cheryl's groceries were $3.10 more than Pam's groceries. How much was each share of the groceries? Okay. So our unknown is like how much each person paid. So we'll use L, P, and C. So the total, so L plus P plus C, should be equal to $89. And so the second sentence says she forgot to save the individual receipts, but remember that Pam's groceries, so let me write this up over here on the side, Pam's groceries were 5 cents cheaper than half of hers. So 1/2 of Lana minus 5 cents. Okay, that's equal to Pam. And so I really don't want this to be in this format. I'm going to subtract 1/2 L from both sides. And then I'm going to multiply both sides by 2. So this is going to get this in a nice form so that we can put this into a matrix, which is kind of what I'm looking for. So, and then I'll even switch these two to keep it in the same order. So we're going to have negative L plus 2P plus 0C. So we'll just leave that off. Equals negative 0.1. And then it says Cheryl's groceries were $310 more than Pam's groceries. So we can make a sentence out of that. Cheryl's groceries are $3.10 more than Pam's groceries. And then I can subtract P from both sides here. So negative P plus C equals 3 to 10. Okay, so now I'm able to get this into a matrix format. So this would be negative P plus C equals yeah. So let's put this in coefficient matrix. So we're going to have 1L, 1P, 1C equals 89. And then negative 1L, 2P, 0C equals negative 0.1. And then 0L, negative 1P, 1C equals 3.1. So these things actually get a lot easier to deal with when you put them in a matrix, which I think is why people like them. Okay, let's do some row ops. Let's do row 1 plus row 2, and we'll store this in row 2. So what I've done is I've chosen this as a pivot, and I'm just going to eliminate everything below it. So I'm going to turn this into a 0. So row 1 plus row 2, so we get 1, 1, 1, 89, so first row hasn't changed. 1 plus negative 1 is 0, that's what we're looking for. 1 plus 2 is 3, 1 plus 0 is 1, and 89 minus 10 cents is going to be 8.90. Then we haven't changed row 3, so we'll leave that alone. And there we have it. Okay, and then we take a new pivot point. That's going to be our new pivot point. We're going to eliminate everything below it. So I think my row operation here, I got to find the LCM of 3 and negative 1, and then make sure that they're opposites. So I'll do row 2 plus 3 times row 3. We're going to put that into row 3. Okay, so we'll keep the first row the same. 1, 1, 1, 89. Second row the same. And then the third row, so 0 plus 0 is 0. 3 plus negative 3 is 0. That's what we were looking for. 1 plus negative 3 is negative 2. And 8890 minus 990 is going to be 79. Let me check it. 8890 minus times. Oh no. So I made a mistake right here. So this is 0, but this is row 2 plus 3 times row 3. So 2 plus 3 times row 1, 2 plus 3 times row 1. Sorry, 1 plus 3 times 1 is 4. That's a big mistake. So 8890 plus 990 is what we're looking for here. So 8890. That's 98.8. That's why it's really important to write these steps down, because there's so many opportunities to make a mistake here. Okay, and then so you can use this to back solve. So 4 times the amount of money that Cheryl made, or Cheryl's bill was, is equal to 98.8. So we can divide both sides by 4, 2470. And then from the second equation, negative L plus, actually, can we use that? Oh, here, let's just use this. So 3 times Pam plus Cheryl equals 88.9. So Cheryl we found was 2470, so the 3 Pam equals 88.9 minus Cheryl, which was 2470. And then so that means that P equals 88.9 minus 24.7 is 64.2. We divide that by 3. We get 21.42. Or I'm sorry, 21.4. And then, so from the first equation here, we should just be able to, let me kind of make some space here. So the first line says essentially Lana plus Pam plus Cheryl equals 89, but we know Pam and Cheryl, so Lana equals 89 minus Pam minus Cheryl, which is 1.4 minus 24.7. Okay, 42.9. So let's actually see if this worked out. So if we add them all together, it should be, the total should be 89. So 42.9 plus 21.4 plus 7 is 89. So that works out. And then the other two sentences, so we should get 2 times, okay, so what is it? So Pam's groceries were 5 cents cheaper than half of her groceries. So half of Lana's groceries is $21.45, and Pam is 5 cents less than that, so that worked out. And then Cheryl's groceries are $3.10 more than Pam's. Cheryl's groceries are, oh, that doesn't work out. No, that doesn't work out. Let's see if I made any mistakes. That is good. That is good. 10 more than M's. Okay. So 11182. So we did row 1 plus row 2. That's good. And we did row 2 plus 3 times row 3, so excuse me. Oh, I think I made a mistake there. 88, 90. 930. I think that's where I made it. So this, so when I did this operation, I just multiplied incorrectly. And so this is 9820. And so this will be super easy to fix. Okay, so Cheryl is 4 times Cheryl equals 9820. It's 2455. Then so okay, so Cheryl we got, and then 3 times Pam plus Cheryl, that's coming from here, equals 88.9. So 3 times Pam equals 88. Okay, so we got disconnected for a second there. So just go back a little bit. Hopefully I wasn't gone too long. So we found Cheryl with this last equation. 4 times C equals 98.2. We divided both sides by 4 and we got Cheryl equals 24.55. Okay. And now I'm going to go backwards into this equation. So this is 3 times Pam plus Cheryl equals 88.9. And so I'll subtract Cheryl from both sides and then divide by 3. So Pam equals 88.9 minus 24.55, all divided by 3. Which is 21.45. And is that 310? Okay, so that worked out. Okay. And then all of them added together is 89. So 9 minus Pam minus Cheryl. It's 43. So I just went up to this equation now. And so we had Lana plus Pam plus Cheryl equals 89. I substituted in Pam and Cheryl and then solved for Lana, and I got 43. Even. Okay, so let's check this. If I add these all up, they equal 89. And then let's take 2 times Pam. Or actually, so Pam's groceries are 5 cents cheaper than half of Laura's. So half of Laura's is $21.50. 5 cents cheaper is $21.45. So that worked out. And then Cheryl's groceries are $3.10 more than Pam's. That also works out. Okay. So these are the correct answers. Lana is 43, Pam is 21.45, and Cheryl is 24.55. So that one's kind of interesting. No. Okay. I don't think I'm going to get to all of these, but get to the first half. Okay, here's the next. Oh, that's the same one. Okay, here we go. Last year at Havens Pond car dealership for a particular model of BMW, Jeep, and Toyota, one could purchase all 3 cars for a total of $140,000. This year, due to inflation, the same cars would cost, okay. The cost of the BMW increased by 7%. Okay, so the cost goes up by some amount, and then they tell you one other relationship. If the price of last year's Jeep was $8,000 less than the price of last year's BMW, what was the price of each of the 3 cars last year? Okay, so our unknown is the price of the cars last year. So we know that the BMW plus the Jeep, actually, let's write this over here. Oops. The BMW plus the Jeep plus the Toyota is equal to $140,000. Now this is the price last year. This year, the cost of the BMW increases by 7%. So the way we write that is 1.07 times the cost last year, plus the Jeep is 1.06 times the cost last year. And then the Toyota is 1.10 times the cost of the Toyota last year. And the new cost is $151,830. So inflation will get you. Then this last sentence says the price of last year's Jeep was $8,000 less than the price of last year's BMW. So the BMW, or so the Jeep is the BMW minus 8,000. And so I'll subtract the BMW from both sides to get negative B plus J, 0T, so I'll just leave that off to keep it square for now, equals negative 8,000. Okay, so let's just get rid of all of these variables here. We'll just use the coefficient matrix, 1, 1, 1, 4, 0, 1, 2, 3, and we've got 1.07, 1.06, and 1.1, 151, 830, and then we've got negative 1, 1, 0, negative 8,000. Okay, so can we do anything here? So this is ugly. Like, this is not a nice matrix. We don't like this, but what are you gonna do? So what is the LCM? So let's choose 1 as our pivot, and we're just going to start eliminating everything below it with row ops. I'm going to do 107 times row 1 minus 100 times row 2. And this is super gross. I don't like doing this, but it'll be fine. It'll just, you know, if you have to use your calculator, and we're going to stick this into row 2. So row 1 doesn't change. Okay, so we're gonna do 107 minus 107 essentially. That's why I chose those numbers, because it's the LCM. Then we're gonna do 107 minus 106, which is, oh, sorry about the barking. Let me just pick him up. Hey, friend, why are you yelling?
Who knows?
Why are you yelling, bud? Oh, good for him. Now he's going to be on YouTube. He's going to be a YouTube sensation.
He is?
Yeah, I don't know, maybe.
That's your shtick?
My shtick?
Yeah.
I wish it could just be
Good job, mathematician.
a guy who teaches math. But
No,
maybe it's a guy who tries to teach math while his dog eats his headphones. Because that's what he's going to do in like 2 seconds. Okay. Okay, say hi. Say hi. Say puppy hi. And then sit down quietly and be good. Or you can just bite me. That'll be also good. Yeah, you're going to fall if you don't sit down. All right. So what have we done here? So we did 107 minus 106. And now we're going to do 107 minus 110, which is negative 3. Okay, the thing we're going to need the calculator for is going to be this one. So we need, oh goodness gracious, you're going to fall on your puppy bum. 1, 4, actually, want him? Say bye to YouTube. Thank you. Okay, so we're going to do 107 times 140,000 minus 100 times 151,830. I'm getting negative 203,000. Okay, and then we're not changing row 3 in this step, so we'll just keep it the same. Now to eliminate the negative 1 in row 3, we just add row 1 in row 3. And that's going to go into the new row 3. Okay, so row 1 plus row 3, we got 1 plus, actually, let me copy the first 2 rows down. So we'll have 1, 1, 1, 1, 4, 0, 0, 0, 0. We'll have 0, 1, negative 3, negative 203, 0, 0, 0. And then, okay, so row 1 plus row 3, this gives us 0. 1 plus 1 is 2. 1 plus 0 is 1. And then 140,000 minus 8,000 gives us 132,000. And let's see what else we can do. All right, so here's our new matrix, and we need to do some row operations on this guy. So this is my new pivot, and I'm gonna eliminate this. I'm gonna do 2 times row 2 minus row 3, and that's gonna go into row 3. So this should be our last row operation. So let's copy down everything the same in row 1 and 2. So 1, 1, 1, 1, 4, 0, 2, 3. We'll go 0, 1, negative 3, negative 203, 1, 2, 3. Okay, so 2 times 1 is 2, minus 2 is 0. So 0, 0. Negative 6 minus 1 is negative 7. And then we've got 2 times negative 203. Negative 5, 3, 8, 2, 3. Okay, so here we've got an upper triangularized matrix, and so once we do this, we can just back solve. So we know that negative 7 times the Toyota is equal to negative 5, 3, 8, 0, 0, 0. So we just divide both sides by negative 7, and we get 76857. Let's write this down. So 76857 point 14, and it's like 0.14286. I'm just gonna like round it down. Oh, it says round to the nearest integer. Okay, so I'll round to the nearest integer. Okay, so there we have it, rounded to the nearest integer. And then we can take this answer and we're going to plug that into the equation above, which says 1 Jeep minus 3 Toyotas equals negative 20323. And so we know what Toyota is, so we can plug that in and then solve. So the Jeep equals negative 20323 plus 3 times the price of the Toyota. So I'm just going to plug that in my calculator. 203 and this one ends up being 27571. Okay, 27,571. And then we know that the sum of all of these things equals 140,000, so I can use that to solve the last one. 140. Equals 35572. So if this seems tedious, it is. It's really tedious. This is terrible. But the good news is that there are computer software packages designed to do this for you, so that you don't need to actually do this. The hard part for you will be to actually set up the equations. Like solving them is really trivial, and there's an algorithm that does it. And it's the same thing that we're doing every time. Like you choose a pivot point, you eliminate below. Choose the next pivot point, eliminate below. Choose the next pivot point, eliminate below, and so on until it's upper triangularized. And then you just back solve. And the computer, is programmed to save the steps that you did, these row operations actually that I'm pointing at the screen. These row operations that I'm kind of like recording. The computer records them in the same way. And what it will do is it'll know how to back solve based off of that. And then you have your values. So the computer is excellent at doing this. This is something that's really important for machine learning, artificial intelligence, statistics. Like matrix math is really, really important for all of those things. Okay. Let's see, do I have time for another one? Let me just look and see when my next student is. Oh man. I've got 2 streaming windows up. It's the same thing too. Okay. Y'all, please like the video and comment, and actually say stuff in the chat if there's any confusion. Let me know. Actually, I wonder if this is not just me watching the same video twice. I don't think I have it open on my phone. Let me close one of these guys. Let's see if that doesn't take the viewers down to 1. I can never really tell if there are actually 2 people in these things. All right, and then I'm just going to download the attachments from this email. Okay, bunch more problems. I'm going to do a couple more, but I got a student coming up soon, so I'm going to have to get it wrapped up. All right. Okay, so this one says solve the system of nonlinear equations using substitution. Okay, so we want to use substitution here. So the first equation is solved for y already. So that's like a really natural substitution. So if y is equal to x minus 2, I can take the second equation, x squared plus y squared, but here I'm going to substitute in x minus 2 for y. A big common mistake is to forget to square it right there. And I know this is equal to 4. So I took equation 2 and I substituted in for y x minus 2, if it's not clear what I did there. So now we just need to expand and solve. So this is x squared. Now we're going to FOIL these out. I get x squared minus 4x plus 4 equal to 4. And then combine like terms, we get 2x squared minus 4x equals 0. So I subtracted 4 from both sides in the same step. Actually, let me not do that. Plus 4 equals 4. Now I'll subtract 4 from both sides. So we get 2x squared minus 4x equals 0. Now this is a quadratic, so we're going to use the zero product principle, and I'm going to factor this. I'm going to take out the GCF, the greatest common factor of 2x. And what I'm left with is x minus 2. So Check my work there. Make sure that's correct. If this is true, either 2x equals 0 or x minus 2 equals 0. And so we can just, 2x equals 0 or x minus 2 equals 0. So that means x equals 0 or x equals 2. So these should both be solutions to that quadratic, right? Now we need to take both of these separately, substitute them back, and see what y equals, okay? So we also need to be careful not to lose a root. So let's substitute these into the second equation. All right, so I'm going to take x equals 0 first and substitute that into the second equation. So 0 squared plus y squared equals 4, which means that y squared equals 4. And we can solve this by the square root method. So we get y equals plus or minus 2. And then now I'm going to substitute 2 into the same equation, and into the second equation. So 2 squared plus y squared equals 4. 2 squared is 4, so I'll subtract that from both sides. Y squared equals 0, which means y equals 0. So if x equals 0, we could get these two solutions. We would get 0, negative 2, or 0, positive 2. And if x equals 2, so we used x equals 2 here, then y equals 0, so 2, 0 is the third possible solution. But how many solutions should we have here? We should only have 2. So let's see. Let's check and make sure both of these solve both equations. Do these solve the first equation? 0, negative 2. So if x equals 0, y is negative 2. That works out. If x is 0, y is positive 2. This does not work out. So if I substitute this into the first equation, let me do that. So we've got y equals x minus 2. So I'm going to substitute this point into there. Y is 2, x is 0. And so 2 does not equal negative 2. Okay, 2 does not equal negative 2. What this means is that this particular solution, it is a solution to the second equation. If you plug that into the second equation, it would solve it. But it does not solve the first equation. So that means it's extraneous, it's extra. So we just want to throw this guy out. He's gone. But 0, negative 2 solves both of them, and 2, 0 solves both of them. Now, for a lot of people, this is really, really confusing. Systems of equations is really, really confusing. Actually, let me write these down before I get too far ahead of myself. The smaller x value. So it's important to be careful with how you enter these. They want the smaller x value. So this is going to be 0, negative 2. And then the larger x value, this is going to be 2, 0. And you don't want to put the parentheses since they already have those out front. So if you've never used this website, it's complete garbage. And if anyone that works at that company wants to fight me in real life, that's a good idea. Let's do that. Okay. So how can we understand what's going on here? Let's just draw some axes and plot these two shapes, okay? So the first one is x squared plus y squared equals 4. This is a circle centered at the origin with radius 2.